Hi, in the last session, we learned how to design a PWM signal and how to control its PWM duty cycle and how to control its PWM cycle. And now in this session, we will design it in VHDL and then we will implement it on real FPGA board. So quick brief that what we are using and what we are designing. We will use our own board 50 megahertz clock frequency for our counter. We will design a PWM signal with 1 hertz cycle and with 50% duty cycle. So what we need for that? We need a counter which will count 50 million times, means from 0 to 49 999, right? And then we will need duty value. So for 50% duty cycle, we will have this value like 25 million. So we already explained this in our last session that from where these numbers are coming. So if you are not clear about these numbers, then please watch my last session first. That is really important. So now we will move to our quarter software and let's design this in VST. Okay, so let's open Quarters Prime software. So click on Start button, write Quarters. We will open this Quarters 2 10.1 web edition because we are working on the Cyclone 2 device and the recent Quarters release is not supported that old FPGA. So we are having this old version and this supports Cyclone 2 device. So this is the startup window. Now we are creating a new project. So we have this button here for creating a new project. So we will click on it. Okay. Now this is the new project wizard. So click on next. Now here I will give my project directory and my project name. So first I will select the directory. So I am making a new folder here for this new project and give it some name. Suppose my project name is PWM underscore LED. Okay. Now select it. I will copy this. Now select it and okay. Now give the project name. So I will copy the same name PWM underscore LED here and then I will click on next. Now this is the add files page. So if you are working on some big project and if you are going to use any existing VHDL file, so you can add your files here. You just need to click on these three dots and then you can add your files in this project. Okay. But we are working on a fresh new project. So we don't have any file to add at this moment. So I will just leave it blank and click on next. Now this is an important step because we are working on the FPGA device. So we need to select our device in this page. So like I said, I am working on Cyclone 2 device. So I will select it from here. So Cyclone 2. Now you can see there are many devices here, right? And we have few filters here that we can use to shorten this list. Like we can select package from here. So my package is FQFP. Then there is a pin count. So I can select my device based on my pin count. So my device has 208 number of pins. So I will select it and then speed grade. So I know that my device has 8 speed grade. So you can see this has filtered out only 4 devices. So I can choose my device from this list now. So I have this FPGA device EP2C5Q208C8. So this means that we have PQFP package, 208 number of pins and 8 is the speed grade, right? 2C is Cyclone 2. Now once you select your device, then click on next. You can select your tools here. For example, if you're doing the simulation, then you can select it from here. For example, Quista simulator you wanted to use, right? And then select the format. So you are working on VHDL, so select VHDL if you are doing the simulation. But we are not doing the simulation, so it doesn't matter. Now click on next. So this is the summary page. So this is showing that what we have selected in the previous steps, right? For example, we have Cyclone 2 device. This is device name. Project name is this. This is the location where my project is saved. Quista Simulator we have selected. So these have some summary information. Now just review it and click on finish. Now Quartus have created a project for you. So you can see this PWM LED is here. So Quartus has created this project for you. This is our project navigator window, and this is the hierarchy view. We have more views like files view. Now because we are working on the fresh project, so that is why there is no file here, because we have not created it yet, and even we have not added any files during the initial steps, right? So this is file section. Every file will be displayed here once it is created or imported, and this is hierarchy view. So this view is important when you're working on some big project, which is having many number of modules and components in a bigger system. So everything will be displayed here in a hierarchy view. So this view is very important. Next, this is the task section. So you are having many of things here. For example, this compile design. Here everything is grouped together based on their jobs or functions. For example, this analysis and synthesis. So this is the first step after you write your code, because this will compile your program and will check for the any syntax error if it is having, and it will tell you that where it is syntax is happening. Next, we have this place and route option. Now before this, if you expand this analysis and synthesis port, then you will see many tools inside it. For example, this RTL viewer. You can use this to view the RTL schematic of your VHDL design. Next thing which we will use, that is pin planner. And what it will do, that you will define your input output ports in your VHDL module, and your FPGA will have many number of input output pins. So using this pin planner, you will tell to this Quartus software that this pin or this port is connected to this FPGA pin. So this is very important when you are working on the FPGA devices. Now collapse this analysis and synthesis, and next we have this assembler. So once you compiled your design and if you see everything is good, you gave the pin planner and everything is okay, then you need to generate programming file, that is binary file, and that will be generated using this tool, assembler generate programming files. Now let's go down. Then you will see this program device or open programmer, and we will be using this tool to program our design into the FPGA. So these are couple of tools which we will be using in this session. Although these options also available at this top section. So you can directly use these buttons for these operations. For example, this is our programmer button. So you can just click it and open the programmer. You can also open from here, and you can also open from here. Now this play button is actually your compile design. So start compilation. So you can use this button to start compilation of your VHDL design. You can also do this from here, and you can also do this from here, right? Now let's create a new project. So here is a button that is for new file. Okay. You can also open by going to file menu and click on new. You can also press Ctrl N from the keyboard. So everything will open the same thing. So I will click on this new button. Then this window will open, that is having lot of things, but we are working on the VHDL programming language, right? So we will select this VHDL file and then click on OK. Now this is our editor where we will write our VHDL program. Okay. But before this, if you notice, this file name is vhdl1.vsd. So Quartus automatically gives this kind of name like vhdl1.vsd, vhdl2.vsd. And I personally do not like this. So before writing the VHDL code, we will save this as per the relevant name, right? So first I will save this file. So I will click on File and click on Save As. So I will save it. Now I will select my project. So my project name is PWM LED, right? So I will select it. So this is the default directory of your project, and you can save your file here itself. But personally, I do not like it. So what I want to save my VHDL file in the separate folder. So I will click on this, click on new folder, and I will give it some name like SRC. That is acronym of source. So I know that all of my VHDL file or source file are present in this folder. Okay. So my project name is PWM underscore LED. This is .vsd file, and then everything is good. Click on save. So you can see that this name is source underscore PWM underscore LED .vsd. And this is much better, right? So now it's time to write our code. So start our code. First, we will give the library and package declaration. So give it library IEEE use IEEE dot std underscore logic underscore 164 dot all. Now we will give the entity declaration, right? So write the entity, then entity PWM underscore LED1 is port bracket start and bracket close semicolon and entity. So this is our entity structure. Now give the input output ports. So what I have clock as an input. So give it std underscore logic, and we are having one LED output. So write it, that is LED, and this is output type, then std underscore logic. Right? So everything is good. This is our entity declaration. Now it's time for architecture declaration. So start it. So architecture behave of PWM underscore LED1 is now begin in the last and architecture or and behave, right? So this is our structure of architecture. Okay, so remember from the last session that what we are needing for this PWM signal, we are needing a counter that will count from 0 to 50 million, because we are working on the 50 megahertz clock frequency. So for getting the 1 hertz cycle, we need a counter from 0 to 50 million, right? So write the code for a simple counter. So we will do it in the register process block. So I will start counting process. Then this is a process. Now this is a register process. So clock is in the sensitivity list. Now because I just wanted to make it simple, so I am not giving any reset signal here. But if you want, you can add reset signal as well. So you will add this reset signal as the entity section as well, and here in the sensitivity list. Okay, so let's start this. So we will start it from begin and then in the last and process, right? So this is the minimal structure for this process. Now simply write our basic structure for a registered process block. So this is if rising edge of clock, then and if, right? So what we are doing, that we are counting our counter at each rising edge of clock. So we will write this statement that our counter is counter plus 1. Okay, so this will count at every rising edge, but we are needing few more conditions to count it, right? For example, we want this counter to count 50 million cycles, right? So from 0 to 49,999,999, right? So give that condition that if counter is less than 50 million, so 50, 1, 2, 3, 4, 5, 6, 50 million, then our counter should be 0. Else, so what is happening, that when the counter is less than this 50 million value, then so it should be greater than 50 million, right? So what is happening then, till the time this counter reaches to 50 million, it will count 1 on each rising edge of clock, right? So that is what it is doing. Now terminate this if condition. So and if. Now let's properly format it correctly. It's looking so messy. So if rising edge of clock, then okay, now else. So this will happen, and this is and if. Okay, so this looks better. Now because we are using counter here, but we have not defined it. So quickly define it first. So this is a signal, name is counter. This is integer type, and it is having the range of 0 to 50 million. So 50, 1, 2, 3, 4, 5, 6, right? So till now, what we have did, we have created this process block, and in this process block, we have this rising edge condition. So it is checking rising edge of clock. Now we are saying that when counter reaches this 50 million value, then it will reset to value 0. Okay, so this is our first condition. And if it is less than 50 million value, then it will count at each rising edge of clock. So that's what we are doing. Now suppose we are making this project for a 50% duty cycle for a PWM signal. So for that, we will use this counter to select the duty cycle of our PWM signal. So what I am doing, that I am writing another if condition, and I am giving the condition that if counter is greater than 25 million, so 25,000,000, then what will happen? This LED output will get 1, logical 1 as an output. Else when counter is less than 25 million, then what will happen? This LED will get logical 0 value. Okay, now terminate this if condition. So and if, so we have defined our LED output and we have defined our counter as well. So here is a quick correction that we have used this 50 million, right? And we are starting our counter from 0. So we are having 1 extra cycle here. So if we want exact 1 second cycle, we will reduce it by 1. So it will be 49,999,999, right? So this is just 1 less from 50 million value. Okay. So because we are starting our counter from 0 and we are needing exact 50 million cycles. And we have explained that in the last session, remember? So if you didn't watch that video and if you are not aware that how to calculate the duty cycle of your PWM signal or how to tune the duty cycle of your PWM signal, then please watch my last video because I have explained everything there, that why we are using this 50 million counter, why this value is 25 million, right? Because we are working on a 50 megahertz clock frequency and we are converting this 50 megahertz clock frequency into the 1 hertz frequency at 50% duty cycle of PWM signal. Okay. So this is our VHDL code for our entity and for our design. So it's time to compile it. Okay. So we can compile it from here, from this button, or you can just double click on this here. So simply click on this compile button. So it is saying to save your file. So I will say yes, save it. Okay, so it is giving some error, right? And we know that what is this error because we have intentionally did this to show you that what is this problem, because many of you will face this. So let me tell you that what is this error. So for that we will go to our source file, means this pwm.led. Now, if you notice that we have the project PWM underscore LED. So Quarters is actually looking for this module, which is named by this name, this PWM underscore LED. And it is actually not finding any file with this module name because this module, which we have designed, that is having the name PWM underscore LED1. So one way is to just change its name like PWM underscore LED so that it can match with your project name, this, okay, PWM underscore LED and PWM underscore LED. So that is one thing which you can do. But another option is you can change this project name itself, right? So right click on it and click on setting. Now, because we have only one single module in this project, so this is our top level entity. So top level entity is the entity which is your final project. So if you click on these 3 dots, you will see all of your designs here. Now, because this is a simple project and it is only having one single file, so that is listed here. But if you are working on some complex project that is having lot of modules and lot of components in your project, then that all of these modules and components will be listed here. And then you need to select your top level module from this list. But for this project, I have this PWM underscore LED1 that we have written in our VHDL program, right? So I will select it and I will click on OK. Now, once you select it, now you need to apply it and click on OK. So you will see that your project name is now changed to PWM underscore LED1. And now it is matching with your entity name as well. So I hope this is clear to you. That means you must have at least one VHDL code matching with your project name. Okay. So that's very important when you're working on Quarter software. So I have changed this. So we will just click on start compilation button. Okay. So it will start compilation. So you can see lot of bars here. These are in progress. So it is saying that my compilation is completed. And this is the compilation report. So switch back to our VHDL project. So what we have did, we have written our VHDL code and we have compiled it successfully without any syntax error. And we have these two ports in our project. So one is the clock frequency that is input to our module, and we have this LED as an output. So we told our Quarter software that we have these two ports, but what we didn't tell that at what FPGA pin these input output ports are connected. So we can do this with the help of pin planner. Okay. So I gave you a brief about this pin planner, right? So it is in analysis and synthesis tool, and you will see pin planner here. Okay. That you will also see at the top here. So this is our pin planner. Sorry, this is our pin planner. So I will open it. Now this is our FPGA device. Okay. So this is Cyclone 2 and EP2C5Q208C8 is our device name. And we have selected this device in the starting. Remember? That is why it is very important to select right device based on your FPGA board. Now this FPGA device having many number of pins. You can see this is side A, this is side B, this is side C, and this is side D. And each side having lot of input output pins or general pins. So if we zoom it little and take the pan tool here and let's drag it little. So this is our starting point and this is our first pin of our FPGA. So if you go down, then 51, 52. So this is side A and that is having total 52 pins here. And then this is side B starting from 53 pin to 104 pin. Next, this is side 3 starting from 105 pin up to 156 pin. And finally, this is going up to 208 pin. So remember, we have selected our device that is having 208 number of pins. So you can see that. Now zoom out this. So what we are doing here in this pin planner, that we are telling that our module inputs and output ports are connected to which pin of this FPGA, right? So you can see these input output ports are listed here, right? So we have this clock as an input and we have this LED as an output. So this is mentioned here, clock input, LED is output. And we have few blank areas as well, which we are going to fill. So location is our pin number of FPGA, like 27, 28, 30, 31, 32, like that, right? So coming here to the location. Now, if you're working on some specific FPGA board, then look at the board specification, that at which pin your clock is connected for your FPGA board, because you must need to tell that where this clock input is connected in your FPGA device, right? So for my device or for my FPGA board, this clock input is connected to pin number 23. So I will type pin underscore 23. So this is the way of giving the location, right? Pin underscore and then give the pin number. Okay. So pin 23. Now our LED output is going to pin number 15. Enter. So remember, you need to mention these input output pins based on your FPGA board, right? So next thing is input output bank. Now this is because our FPGA devices has many number of banks, and each bank has its own individual power source. And these banks can be isolated by each other and can serve by different voltage levels. And that will be specified by your FPGA board manufacturer. That will tell which bank has what power supply. So you can see that these both pins are belongs to this IO bank number 1. Now this is input output standard. Now for this device, this is fixed. You cannot change it, but recent devices are flexible enough where you can set these voltage levels as well. So in our case, this is very strict. Now, one important thing, when you click on this, after giving the location, that will be mentioned in the FPGA device here as well. So you can see that we have connected this clock signal here. So it has marked with a different color. You can see this blue boundary here. So this is selected. Now, if you click on this LED switch, so this will move to here. So we have connected this LED output to this pin. So you can easily see that which input is connected to which pin right from here. Now, if you notice, then there is no save button here. And that is because this pin planner automatically save data when you change it. For example, if you change this, then it will save automatically. So there is no save button. So once you change everything based on your board specification, then you can leave it here and just close this window. And now it is saved for this project. And now we have changed this pin planner. So we need to recompile this program, right? So we will click on this start compilation button once again. So click on it and you can see the bars are started and the processing is happening and the full compilation is completed. Okay, so click on OK. Okay, so this is the compilation report and this is our VHDL code. So now it's time to program this code into the FPGA device. Okay, so for this, we will open this programmer. You will open it from here. Like you have this option, program device, open programmer, and you can open it from here as well. So we will open it. Okay. Now I will expand this little so that you can see everything here, what is available. So this is our file name, that is PWM underscore LED. And this is our device name, that is EP2C5Q208. So note that if you didn't select the right device during the startup steps, then your FPGA will not be programmed properly. Okay, so make sure that you select your FPGA device correctly. Now we have this checksum. This is just for the file validation. Then we have user code. This is FF, means none. Now make sure that this program or configure button is ticked. That is very important. Now we will leave everything blank here and we will check our hardware setup. So we will click on it. Now you must see your USB blaster here in this list. If it is not available here, that means your USB blaster is not connected with the PC or it can be driver problem. So install the driver, reconnect your USB device and then check if your device is visible here or not. And once you see your device here, then just select it and close it. And you will see it from here. USB blaster, USB 0 something. Okay. And we have this progress bar here. So you can see it is progressing during the programming time. Okay. So we will select this PWM file. Now remember about this .sof file. So this file is volatile in nature. Means if you power off your FPGA board, then all the configuration will be wiped out from your device. Means you need to reprogram your FPGA device every time it is powered up. Okay, so click on this device and you will see this start button flashing here. So just click on it and you will see the progress bar. So it is quick, 100% successful. Now we will move to the FPGA board to see if that is working correctly or not. What we are expecting that our LED should glow at a cycle of 1 Hz. Means for half of the second it should be on and for half of the second it should be off. And it should be happen in the repetitive manner. Okay. So half second off, half second on, then half second off, then half second on, like that. Okay, so let's move to the FPGA board and see if it is working fine or not. So you can see that this is our FPGA board, and we have connected this LED to the output port, which we have specified for our FPGA device. And now you can see that it is turning on for half a second, and then it will go off for half a second, then switch on for half a second, and then switch off half a second. So it's on, off, 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 on. Okay, so this was our 1 second PWM signal with 50% of duty cycle, and that is working perfectly fine for this project. So that was our project. We have created a PWM signal of 1 Hz cycle and with 50% duty cycle. And we have used 50 megahertz clock frequency to drive this PWM signal. And at the output, our LED was blinking at 1 second cycle with 50% duty cycle. Means for half a second it was turning on, and for another half second it was turning off. So that's how it works. In the future sessions, we will be designing more systems in VHDL and FPGA. So stay tuned for the update. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.